are going one step below the artificial intelligence part, which is also part of the OC4AI community. And this is namely answering the question, where the hell does all the data come from, if it doesn't come from a CSV file or a stream? So I'm talking about ecosystems, like data spaces. Probably you have heard about that. And we understand, or we know for sure for now, that data from one ecosystems like automotive, manufacturing, defense will not be enough to drive large language models. You need vertical models, which in Europe is called vertical AI, in contrast to the Americans, which do horizontal AI. But you will need data from different ecosystems. By the way, also for supply chain, like digital product passport, so like 600,000 companies in the automotive supply chain, they need this kind of data, but also the AI models. How then do you solve the problem how these ecosystems can agree on a common trust basis? A little bit to what we are doing at Gaia-X and what I'm doing. If you want to understand what Gaia-X is doing, you just really, literally have to read our mission statement and our vision. We only do trust frameworks for digital ecosystems. I know that in 2020, people believed we are building the largest European hyperscaler ever. We were a little bit short of money, like 10, 50 billion euros. Stackit is doing that a little bit, the Schwarz Group, but we never got that funding. But we concentrated in the last 3 or 4 years on the only thing which has not been solved anywhere. And please challenge me, I have not found anywhere else that someone is providing first automatable trust frameworks. I'll show you what it is in a second, for single data spaces, so within a single kind of vertical space, but also between. And that's completely new. And what is also new and discriminates us as an association from other organizations is they do a little bit standardization. They do a lot of mission, evangelization, but we also have software teams, and in the back we have Yassir, my team lead, for the implementation. Because if you have a lot of data, and you have like 10,000 in the Airbus supply chain, and you have a lot of data exchanges, the exchange, the evaluation of your policies and the identities of the other partners in your supply chain has to be automated. So we built that automation, and of course inside open source projects. This is what we do, but I have a little bit more flesh to that, what it really is. Because you have to understand a little bit what a trust framework is before we can show how that would work between ecosystems. And that it's generally accepted. Trust frameworks consists of a little bit of the legal part, the business part, like the requirements specification. You typically have PDF files, and you typically have some kind of governance authority. In Catena-X, that's the Catena-X association. Even for Gaia-X, it's our policy and rules committee who set up the rules how an ecosystem wants to establish trust. And we come to the technical details of that, how an ecosystem establishes trust. So whom to trust? Like in PKI, what are my trust anchors? And at the lower level, this is where the code sits, but not just code, but also operational procedure. If you look at not just the software components, but also the operational processes, this is KYB, know your business. In Catena-X, you get, if you want to participate, a little bit of a know your business kind of evaluation. Is that a legit supplier in my supply chain before they give you a BPN number or some other shenanigans? And of course, the actors are like clearinghouses, one or more federated, and automation in the form, of course, of software. We know that there are a lot of different trust frameworks out there. iShare is an important one. eIDAS, of course, is also a trust framework. But none of those solve the question, how can you establish trust between iShare and Gaia-X and eIDAS? So that's completely new, and no one else has covered that, unless you provide a contrary example. Trust, unfortunately, and there is unanimous agreement, both in practice and in the academic literature since 1985 or something like that, is very hard to capture. In ISO and its Senelec, we tried to do that. I'm also an editor of a standard in that for trust frameworks. So we tried to do that. So if you want to have a definition, which is currently being, actually this one is from Senelec, then stick to those. The standard actually has already been finalized, but not all the elements which are contained in the slides have been standardized because it's 3 parts. This is kind of really more the fluffy stuff. The meat, the flesh is in the other part, how you automate that. And that's the critical thing. And many people do not understand, if they read the standard, how that would relate to software. And at the top part, you have kind of the idealistic, the legal part of a trust framework, the rules people have to obey, or claims or processors or your IoT devices, the rules they have to obey in order to be trustful. So that's the policies. And then you have someone who brings an IoT device, who brings a connector, or who is an entity. I have a small company and I want to be participant, who then the thing I present to someone is called claim. That's also in ISO 17000. So I provide a claim, look, I'm a legit company, like typically with a registry excerpt from the company house. And then someone needs to check whether the claim and the policy are sufficient, or whether the evidence contained in the claim is sufficient that someone else believes that the policy is met. And that mechanism is called reconciliation. And this is what we automate. Because in reality, you have in a data space, kind of data space, participant agents, aka connectors, and they do all the exchange of the data, and before they start, they get agreement on some access and usage policies. But that has to be automated. If you don't do that and you have a person overseeing like millions of exchanges in any live project, it won't work. So that reconciliation part is the important part, and that has to be automated, of course. Just a few glimpses into how the top part, the business part of a trust framework would look like. You have certain labels, you have definitions in that case, and then there are 2 important things which also spill over into the implementation, and that's how you kind of provide evidence. We are a little bit, this is of course the policy part, so someone is defining that, but every policy, and wait until the end to the learnings, this is important. It's easy to define the policies a little bit, but then you have to find, and this is where declaration comes in and certification. You need to define ways how someone, in our case a machine, is able to check that. And the primitives, the most primitive form is declaration. Someone says, I'm honest. I'm 1 meter 79 centimeters tall. Of course, if you trust the person and you can make it liable, the best form of assurance you can get is called in ISO certification. That is that you do not trust myself or my wife measuring me, but I go to a physician, and the physician acts as a so-called conformity assessment body. But whom would you take? I mean, for physical height, that's a physician. For identity of a company, that would be the company registry. But for compliance with, I don't know, Secnum Cloud, who is that? You need to find those trust service providers. That is crucial for implementation. But that's all written in such a trust framework. So we get that in Gaia-X. We have done that for service credentials, for service policies. We have done that, but this is just a PDF. How would you automate that? And unfortunately, there is currently no universal policy definition language where you can automate everything. ODRL, the Open Data Rights language, does not have a common semantic for execution. There is not even an engine. Rego is a little bit descriptive, of course, to some extent, but also not used for the trust frameworks on the preceding side. So what we did, because our Policy and Rules Committee developed very complex patterns and very complex policies, we had actually a manual At that time, 3 years ago, Cloud Code was not available at all. So we had manual translation from the rules on the previous slide into mem graphs or whatever. Because that will be, for every single rule in a database or ecosystem, the critical part. You have someone who defines well-intentioned rules, and then you need somehow to come to an execution environment. So the normal engines, the universal engines, are not totally available. ODRL cannot even capture all potential policies, time-ordered policies. It doesn't have causal inference, for instance. So we will have a little bit of development effort for any compliance engines. However, only if you have very extended rule sets. So this is what our compliance engine does. So, and this is, of course, done by part of my team, headed by Yassi in the back. So this is what differentiates us from other organizations in the database arena, because they give good advice, but no software. And good advice is nice, but without software, you don't get anything. Or you have to do everything yourself, which is the other thing. So if we look into a single data system, a data ecosystem, that works. But we had actually, together with other ecosystems, a request from our policy and rules committee, from our members basically. Initially, everything was monolithic. So we had one compliance document, the thing I showed 2 slides before. We had some compliance engines which implemented a certain set of standards, but actually it was a monolith. Every ecosystem would have to install that engine, and interoperability, of course, would be solved because there is one engine to rule them all. And then people discovered 2 years ago that this form of rules does not fit every ecosystem. So Catena-X has different ecosystems, SCSN, iShare, they all have a little bit different ecosystem rules. So we wouldn't be able to accommodate them. But then we developed, together with the Policy and Rules Committee, at the top layer, and you see the distinction between the kind of the law, the legal part, and the technical part on the bottom. They developed a mechanism how to extend our once very closed compliance document with all the policies. Yeah, I will share the presentation with you. If you send me an email, it will also be on the web page later on. And then we also invented an idea where an ecosystem says, oh, that's all nice, Gaia-X, what you have been doing here. I need complete another set of rules. And we had the request that we also need to be able to kind of implement that. But if you look at that, you have one ecosystem, it's just Gaia-X. The other one does a little bit playing around and adds a little bit of flavor. And then we have other bring your own rules who are completely different. And then we remember, and we know that also from our members, that this ecosystem needs to talk to that one and the other. How would that be able? And then they would, of course, come back to Gaia-X and say, hey, guys, we are implementing your rules, and they don't work together. And that was an idea which is captured in that Gaia-X technical compatibility, which we actually have been thinking of 4 or 5 years already, that all these different engines for compliance, for the different policies, that they would work against the same set of standards. And if you look into our architecture document, you'll find that VC-JOT, DID Web, JOT, VC-JOT, whatever. However, what we also wanted to provide to kickstart ecosystems, software which allows them in a technically compatible way, so across all the ecosystems, with the same set of standards, implement different rule sets. How would you do that? And this is the Danube architecture, which we released last year. It's a very straightforward architecture based on the requirements. We had, of course, something like a dispatcher, and then you have, we called it extension, that's not so important. But you see that within a single execution context, and that could be Kubernetes, doesn't need to be, but that you are able to run, to execute, and to manage different compliance domains. We call it extensions, compliance extension. And maybe they have some outside registries or so, we don't care, because this is the microservice IMX, International Manufacturing X, has, of course, we have built for them a very small compliance engine. And then we have, we call that local for other reasons. And then we have our own big one from the past, the LOA compliance engine. We also know from iShare that they have big other compliance engines, which we will not be able to move into that kind of Danube platform. And for that, we invented the idea of having some proxies and doing something which we call remote extensions, compliance extensions. One thing which is important for this audience, because this is completely new, not just for us, but also for the ecosystems. It's not like Yassir and I and Pierre, our Chief Innovation Officer, that we get together once a year and develop the ultimate vision of how that looks like. Yes, we do that, but at the same time, we work together with our ecosystems in a co-innovation, co-development form to understand their needs. And in the next step, if someone of you is an ecosystem and says, oh, Christoph, I don't need it, I need something else, I don't know, I need an iShare implementation or something like that, then we would prioritize that. Because our belief, and I know that from IoT, it's not, we do not, as technical guys, we are not the best ones to preempt your business requirements. That would be you as an ecosystem. But let's work together to make the most of it, and that's called co-innovation. In IoT, that worked for the last 15 years very well, and we're doing the same. So very simple architecture, and the layer at the bottom, it's like basic functions, where we implement a few, and this is the current slate of functions, a few things. And if you use that layer, by default, you are Gaia-X technically compatible. So that's kind of the bonus you get when you use the platform, that you for free or automatically become Gaia-X technically compatible. So any ecosystem which is using that platform and is making use of that kind of technical compatibility layer implemented in software will automatically be interoperable at the level of trust. That's the promise of that. You can, of course, say, I don't want that software, implement everything ourselves. That's also possible, but only a few ecosystems do that. It takes about 2.5 years, 3 or 4 developers. Be my guest. Perfectly possible, but that's not how ecosystem starts, because no one is interested in investing into 2 years effort for developing something which they can get for free and then extend and have us extend it. So that's Danube. And this will be, initially it was just a helper function for the dispatcher, and this will be a prime ingredient for solving the trust, the trust dilemma between ecosystems. But that's too early for that. Let's first, before we jump to the solution, sketch the problem. I have already sketched in one of the earlier slides that you have different ecosystems. How can they trust each other? And we implemented a use case actually for the last 6 months with the International Manufacturing X Council. Normally, for the International Manufacturing X guys and ladies, everything is at the top. But at the bottom, they need some trust service providers, because you cannot trust all the OPC UA machines, all the standards. You need a participant identity in your ecosystems. So one ecosystems, the manufacturing guys, Cofinity X, they have that. And then you have an adjacent ecosystem. In our case, it was a little bit logistics, supply chain, who do similar things. They also have a notion of, oh, I have a Japanese company registry for identifying Japanese companies or South Korean ones. And then you have another adjacent ecosystems like the users downstream, the customers of the manufacturers, who also form an ecosystem of their own. And in classical data space, how should I say, consulting and implementation approaches, you have one ecosystem, very egotistically developing their set of rules and policies, including their trust service providers. We only trust the Deutsche Staatsdruckerei for our credentials. We only trust Cofinity for handing out participant credentials, which is fine for that one. It's also fine for the Japanese guys to define someone else, and also for the usage. The key question then, and we call that, the key question then, if I'm a participant in, I'm a manufacturing company, and I want to have a link using data space technology with my logistics supplier, because I need to get some input from my raw material providers, or I need to hire and manage some lorries, some supply chain things for my customers. And those guys sit in the other ecosystems. How do you do that when they have selected completely independent from myself, from my ecosystem, they have selected other trust anchors? How can we do that? And actually what we did is we copied the way how you do that in real life when you send PDFs or faxes. These ecosystems normally would also select company registries in Canada, in Japan, whom they trust. You would not trust all the other trust service providers from the other ecosystems because maybe they are shady. And also the Japanese or the other ecosystems will select a few. Probably the Japanese ecosystems will trust either two trust service providers. I mean, honestly, they will. If you do the business like sending roses or receiving roses from Kenya, I bet you will trust the Kenya Revenue Authority, because that's the only authority they are giving out digital identifiers for Kenyan companies. If you go do business with the UK, you will trust the UK company house. There is nothing else. But on a technical implementation and automation level, what would that mean? It means that you have kind of a trust profile with your own trust service providers, but you also include on that side the Japanese ones. And this kind of the intersection, the union of all those common trust anchors, that would go into the Gaia-X meta registry together, actually, and this is a technicality I'll show you later, together with the things they are trusted for, because potentially not every trust service provider is trusted for everything else. Let's look into a little bit in more detail how that is implemented actually, and this is running. So this is not like an idea, but we have been implementing that since Danube it was live since last August. So that's all operational. So you have the Gaia-X ecosystem, and that's only abbreviated. It's not so simple. And you have some clearinghouses as trust anchors, and then you have, in that case, it was a Canadian manufacturing ecosystem, or the IMX, with some other trust anchors and trust service providers. And they all have a registry, which is a simple database, maybe distributed, where you all list the trust service providers, the credentials they are allowed to issue, whom you trust, and also the first element here of these triples, which this is what we call a trust scope. I'll show you later why that is interesting. Strictly speaking, it's not necessary, but it has fantastically mathematical properties, which makes interoperability easy for many ecosystems. Gaia-X has that, and Canada has that as well. And then simply, literally, in our meta registry, you select from a Gaia-X side, oh, I don't trust, for instance, Constellation, for whatever reasons. The ecosystems decide this is made up, so that's not the reality. In IMX, we have that better. So we trust a few of the other trust service providers for their credentials, and vice versa. And normally, you could stop here, because that's all what is needed if you stay within Gaia-X, the technical compatibility, that's all you need. But this is not going to work, because this ecosystem doesn't know what the trust anchors of the other ecosystems, and vice versa. So we actually invented the Gaia-X meta registry as a vehicle to put together, to collect all those trust service providers which ecosystems share with each other. So that the Japanese participants can look up, if I want to do business with the Gaia-X ecosystems, oh, whom would I trust? Ah, Neustar Aerospace. So if I get a credential from Neustar Aerospace, I can automatically exchange data with the other ecosystems. If I do that with someone else, for instance, with Delta DAO, that would not work. because we do not accept that for whatever reasons. So that's the idea. You mutually specify and accept trust anchors, trust service providers from the other ecosystem. And that can be done and will be done by every ecosystem totally autonomously. There is no governance entity in the world which can tell the Japanese or the Canadian whom to choose. They will choose their set of trust anchors and whom they trust. And Gaia-X or any other ecosystem will choose their own and the foreign ones. Totally autonomous. No one can change that. There will never be a super United Nations trust registry for all whom we trust. No governance entity in the world will be on top of ecosystems. If they agree, the meta registry will show. So if they find common ground. If they don't find common ground, we cannot solve that technically. That's an organizational, a governance issue. We can't do that. We can't force. We cannot tell autonomous ecosystems whom to choose as trust service providers. And we call that the trust dilemma. So you can't do that. If they do not want to agree, you don't get it. If they agree, then that's the mechanism to go for, because then you get universally accepted. This is how we present that actually to end users. They will not have to look directly into the meta registry, but some kind of catalog. And this is actually work in progress, because ecosystems progress in their trust service providers, in the credentials. So this is live. Actually, if you go to CeBIT, to Hannover Fair, sorry, I will be there the rest of the week. We can show you that live, how that looks like. So it's not that the JSON files will not be exposed, but something like that. And we also developed very small kind of credential ontologies, because everything has to be automated. And the lingua franca for exchanging claims and evidences, honestly, is verifiable credentials. If someone tells me you have to use something else, I don't think that's going to fly. The whole world, those parts of the world who are embarking on that, but please challenge us and the whole ecosystems, are using verifiable credential data model too. So that's kind of, then you see that here. And what you also see is several interesting things which in real life will be important. So that's a credential by an application. So you have for an application, you have a trust service provider who says that your application conforms to, I don't know, the Cyber Resilience Act. But then you have typically some entry somewhere in the credential which says, yeah, but that's only valid if it's operated by one of the participants. So you can, of course, with the IDs and linked data, so JSON LD is also mandatory. So if you just specify JSON, we can't work, because then it's, if you don't have a context, it's not interoperable. You are really doomed. So that will then link back to participants, and these kind of very simple kind of verifiable credential data models are also easy to implement, also in form of a compliance engine. So the IMX use cases, which are based on real digital product passport use cases, they are not so complicated initially. If you look at the Gaia-X service credential, it had 62 other credentials inside. That's the full breadth. After 2 years or 3 years of working, you arrive at that, but you don't start with that. You start with something like that, and then over time it will get more complex. We have other device credentials, etc., which share similar elements. The most important, but not so interesting actually, is the provider credential, which is kind of a participant credential, but that's not in the focus. We will come back in the learnings, in our experiences, how that relates to that. And you see, we also have operated by something like that. We invented, because we are also basing the meta registry on JSON LD, we invented a very small ontology. And if you remember the triple with a trust scope, a trust service provider, and the credentials the trust service provider is accepted to provide for that scope, that's simply implemented. So that's the raw ontology. At the last page, you will find a link to the ontology where you can find it implemented in OWL, including shackle shapes if you want to check whether something conforms to that. So very simple, And one important thing is, which is often overlooked, the classical data space and ecosystem theory says you have to have kind of organizations as participant in an ecosystem. Our ontology does not specify what type of participants we accept or not. You can have, for instance, IoT devices, like you can have an OPC-UA compliant ecosystem of devices and servers who are compliant, and no participant credential in the sense that an organization is paying Catena-X, I don't know, a fee for being member, or Gaia-X or something like that. The ontology provides that. This is actually an approach, a best practice, a pattern in standardization. We also see that in the IP protocol, and it's called under specification. If you don't need to specify what is a member credential or so, then don't. The ecosystems will kind of find that. Yeah, we also have, of course, the trust profile, and I showed it just for completeness reasons and also for purposes of education. If you look at real trust profiles, which you can find on our web page, we simply followed the ontology. So there is no, it's not like, how shall I say it, rocket science. You do not have to learn category theory or matrix multiplication. It's not like holomorphic computing, which is really kind of, or zero knowledge proofs, which is mathematically kind of really weird. And I'm a theoretical physicist, so I understand, I can deal with quantum computers and quantum mechanics. So that's really simple. You just have to do it. And I think the difficult part is not that one, but as we will see later, agreeing on what we specify in that kind of language. So that's very easy, and I've already provided a link. So that's really trivial almost. And if you follow this kind of triple patterns, everyone else would be able to discover your trust services and providers in the meta registry and can then pick and choose whether they also would like to trust them or not. Yeah, that's the trust proposition. We also actually have developed a mathematical theory for that. If someone is really into set theory and a little bit of, it's not category theory, but it's applied set theory and relations theory. If you know mathematical notations, you will find all the elements which I have in the first slide said, oh, this is a trust proposition, scope, etc. You will just find it rigorously defined so that it makes sense. And we discovered a very nice property, and also the kind of, if two ecosystems agree on some trust proposition, like trust service providers, that's here. That's exactly the thing which makes the property of shared trust very nice, because then, and this is actually a mathematical proof, because if everyone, if for some trust scope, like participant credentials, we find, every ecosystem finds kind of one trust service providers whom they trust, and that is shared, or you have a chain of shared elements, then you get almost universal interoperability at the level of trust. If someone says, no, I'm out, you don't get it. And you will not be able to stop that ecosystem from doing that. Yeah, it's like with measurements or other standards. If you don't adopt it as a country, then you are out, and you have to pay the price for that. We will also, Judith and I have written a paper on that, or actually a book article, like 25 pages, which is due later this year. We are waiting for some reviewer feedback. So if we have a TechX actually in May. By that, we should have a final version available. It will be open access. So if anyone wants to kind of read what I have just told you, and with a similar background, a little bit more kind of structured or more rigorously formulated, then just drop me a note and you can get a preprint of that. So we really wanted to make sure that this is not something which you lightly say, we have a trust framework and it solves interoperability. So this, we really put some thoughts and tried it out with IMX at Nuremberg in Hanover. We are there. We will present one or two cases of a successful application of that at the end of May at our TechX. So both theoretically and practically that works. You can also communicate that, because it's not rocket science. You can communicate that, even though trust is a very elusive concept. We tried it with Japan and Canada, and people are able to follow that line of thinking. I don't say it's totally easy, but they understand that, and they can also implement the software. We tried it out. What did we learn the last 1.5 years doing so? And actually, we have two kind of learnings, or two areas where the learning happens. One is very simple and expectedly. It's just coming up with the compliance rules for your ecosystem. That seems to be difficult because, as we learned, actually I learned it at the Data Sharing Festival in Rotterdam a couple of weeks earlier, only 5 to 10% of data spaces have a data space rule book where that has to be described. So they operate like kind of, oh, we have KPN, let's trust KPN, yeah, whatever they do. They have not written it down. And of course, if you do not formalize trust, it's very hard for the other ecosystem to trust your things you are doing if you can't even explain what you are doing yourself. That was very interesting for us to understand. You need to spend some time. It's like requirements engineering. You need to spend some time a little bit. And then we have a little bit also technically related things. Who are my trust anchors or trust service providers? You need to get those companies on board. Otherwise, no one who will issue the credentials you trust. And technically, we only had procedural or very basic findings. This is mostly related to the fact that the workings with verifiable credentials and the tool chain is new for many people. A few companies know PKI, you know, maybe key management is an issue in IoT, but not totally, because they are all username, password. I'm a little bit exaggerating. So that's new. And also working with DIDs. Yeah, if your ecosystem does not work with DIDs, you are out. That's my prognosis. Everyone is using DID. We cannot describe the method, so we're using DID web potentially, and others, you have DID iShare, but that needs to be a decentralized identifier standard. Otherwise, it's really hard to come to terms, and it works very well. If you look at the examples from the IMX, we invented a DID.:IMX identifier, and it works like a charm. The resolution is, of course, not perfect, and people can't work with that. And that's just like, oh, I can't work with my, I don't know, PowerPoint slides and animate it because I'm not used to it. So the technical things will diminish and will vanish in the future. Who is going to do the compliance rules will stay. It's a task for the Data Space Governance Authority. And I also want, I told you about the key management and credential management. And what was interesting is what was not questioned. And these are actually the underlying technical standards. This is kind of a common set. If you are outside of that, it will be hard for your ecosystem. And what was also really nice for us and for Yassir's team is we provided a lot of software for doing that. I'll show you on the next page. We provide all the basic ingredients that you can get started with simple examples, very elaborate examples, so you can get going without having to develop anything from scratch. And that apparently was well accepted over the last half year or 9 months or so, which is also good. And by the way, it also challenges our technology. So the more people who use it, the better the functions, etc., are tested, obviously. And last one, we are Gaia-X. Everything we do is from our members, by our members, but for the broader community. So all of the elements you see here are available to anyone there. So please go to GitLab and clone the project or become a Gaia-X member. So I'll leave it with that. If you want to have more information, just Google us. We have an academy, actually, so that's interesting. We have an academy with also some free courses. So normally, I mean, we are an association, so the members pay my salary and the flight to Brussels. So we can't give away everything for free, then we have a free rider problem and no one would spend anything. So try it out. If not, We have a Slack channel and weekly open source community calls. So drop me a note or something, the Slack invitation link should work every week, and that's a discussion not for the nerds, but for those who care about, it's also for nerds of course, but those who care about the implementation, because that is what the Gaia-X Trust Framework eventually wants to do. You have nice implementation or definitions of your rules, but eventually in large ecosystems, 10,000 in the supply chain of Airbus, all of the nice trust things and policies have to be implemented in software. And you'll get that with the Gaia-X Trust Frameworks, even across ecosystems, and you won't get that from anyone else. Thanks for listening, and I think we are the last before the reception. Thanks a lot for coming. Any questions at this point in time? Yeah, please. Yeah.
I see that the implementation today with Danube is with Delta DAO, that is not a Eclipse data space connector based.
No, that's made up.
So my question is, how far or how near is Eclipse ecosystem implementation of data spaces of supporting Gaia-X Trust Frameworks Danube? On what is the plan for making it compatible, the current implementation with this amazing trust framework?
The current standards and projects in the Eclipse Data Space Working Group are fully compatible and complementary to what the Gaia-X Trust Framework does. Part of the Trust Framework is even a project, a standardization project within the Eclipse Data Space Working Group. That's part of the little bit meta registry CAP. The project is called CAP. So these are complementary standards. The EDWG, the Eclipse Data Space Working Group, provides standards at the level how data exchange happens, the data space protocol, decentralized claims protocol for exchanging. So the Gaia-X Trust Framework is one step above that. And we complement that because that's the technical thing. But before the technical data exchange can commence, you need to check the policies and the claims to whether they match or not. And currently, the Eclipse Data Space Working Group projects do not have that. They leave it open for this time. So this is where our trust framework complements that, and it remains to be seen to what extent the CAP project can evolve into maybe something like a Gaia-X Trust Protocol, which would also go into the EDWG the working group. So that's possible. So today, it's fully complementary. So
okay, complementary.
Yeah. If you go to the standards, DSP doesn't give you a trust framework. DCP, it's completely, it doesn't know how to make your credentials. Really, it's complementary, 100%.
Okay, so the way to go is that you first verify, before making the negotiation using Tractus X, you will verify that the credentials are trustable, and then after you verify, you make the negotiation with the data control plane.
Right, yes, exactly. There is a way, so Antonio is referring to the steps in the data space protocol where you have first a catalog retrieval, then contract negotiation, and in that contract negotiation between data provider and data consumer, you ship around credentials which typically the consumer ships around the credential telling the provider, look, whatever policy the provider has, I am fulfilling the policy. But the EDWG does not define policies in any way, gives you no way how to automate that, in which language and how to structure that, how to define the trust anchors. So the policy reconciliation is complete, at this point in time, completely outside of the specification. This is where we complement it. Because as you have seen, policies, claims, reconciliation, that is where what we provide. And that's nice.
Thank you. Clear.
Any other? Yeah, please.
If I may, are you dealing with the agent systems? So, how to trust an agent?
We have several requests on doing that. The trust framework is open to do that. We have, at the level of the policies, the Policy and Rules Committee, we have an AI sprint, So if you want to become, and if you don't are already, become a member and work in that sprint. We work together with domain experts like in AI agents, how the MCP protocol or A2A would relate or could relate to concepts from the Trust framework. We've identified 10 or so elements like MCP server, identity, training data, or AI agent identity, or something like that. I don't remember that, but that's very fresh. So we don't have a ready solution for that, but we know that several of the questions in such an AI agent ecosystem can be solved by our Trust framework. We need to define the rules and then the implementation. We are working on that, yes, yeah. Yeah, thanks a lot. And enjoy the remaining rest of the evening, and of course the two further days of the OCX 26. Thanks a lot.